Yes, good morning. Today we're going to talk about section 5.4, multiplying polynomials. Well, hopefully recall in 5.3 we defined polynomials and we added and subtracted polynomials, and we also evaluated polynomials at points of interest. Alright, so we laid the groundwork for polynomials down in section 5.3. Now we're going to talk about 5.4, and today we're going to learn how to multiply polynomials. And this is going to be the theme of chapter 5, basically increasing a kind of a tool book or a toolbox of operations that will deal with polynomials. For example, let's talk about a monomial times a monomial. As we know, a monomial is the simplest type of polynomial. How do you multiply monomials? Well, let's say I've got 2y cubed times 4y squared, and you're thinking, well, this is quick work. Multiplication is commutative. That means I can take any of these factors and multiply them together. Typically, we'll multiply the coefficients first. 4 times 2 is 8. Y cubed times y squared is, of course, y to the fifth. So my return for that simple example would be y to the fifth. Again, maybe a more interesting monomial times monomial. Let's say I've got 36 m to the fourth power times n. That's a monomial of degree 5 times 1/9 m to the 8th n to the 6th. It's a monomial of degree 14. Alright, I'll multiply the coefficients together first. 36 times 1/9 reduces to a 4. M to the 4th times m to the 8th is m to the 12th. And again, n is n to the first power times n to the 6th power is n to the 7th power. So return there would be 4 m to the 12th times n to the 7th. Alright, up the ladder we go. Once we are conversant in monomials times monomials, let's talk about monomials times binomials. Oh, it's a simple example. 3x squared times 6x to the 6x to the 6th power plus 4x squared. Alright, I'm sure you spot that we need to apply the distributive law here. In other words, multiply 3x squared, the monomial, times both factors of that binomial independently. Alright, so 3x squared times 6x to the 6th power is going to be 18x to the 8th power. And then 3x squared times 4, positive 4x squared, is going to be plus 12 x to the 4th power. So final return 18x to the 8th plus 12 x to the 4th. Alright, so that's a simple example of monomial times binomial. Well, suppose we've got a trinomial. Well, I just think you can appreciate we'll do essentially the same thing, distributing our monomial factor across all terms of the polynomial. Here it's a trinomial we're multiplying by. Make sure I write this down right. Minus 2ab squared times 3a cubed b minus 2a squared b plus 4b squared. Again, we'll apply our distributive law. This is my monomial factor. I want to multiply each factor, each term of that trinomial independently, and hopefully simplify the result. Alright, minus 2ab squared times 3a cubed b, that will give me a minus 6a to the 4th power b cubed. Will it not? Now I'll take this monomial times this factor. Minus 2 times minus 2 is plus 4, multiplying the coefficients. A times a squared is a cubed, times b squared times b is b cubed. So I'll get plus 4a cubed b cubed. And again, this monomial times this last factor will give me a minus 8a b to the 4th power. So there's my final return, minus 6a to the fourth b cubed plus 4a cubed b cubed minus 8ab to the fourth. Alright, how about a monomial times any polynomial? All we do is use the distributive law, distribute your monomial factor properly, and of course simplify according to your rules for exponents. Yeah, hang on. Yes, we'll use our distributive law along with our rules for exponents to hopefully simplify sometimes quite complicated expressions. Let's look at this one. This is a nasty looking binomial with three variables. Remember, it's a binomial because it's a sum of two monomials, or difference of two monomials. And I'm going to multiply this by a three-term or three-variable monomial. Alright, the motif is the same. This is a product, so again I can multiply left to right or right to left. I'm going to take each term of this binomial and multiply it by 5x cubed y squared z to the fifth as indicated. Alright, let me do this times this. I get 5x to the fourth power, y to the fifth power, z to the seventh power. Now minus, because I got a negative 2 here, again this times this is going to be, I'll get a minus 10 multiplying the coefficients times x to the fifth, y times y squared is y cubed, and z to the first power times z to the fifth power is z to the sixth power. So 5x to the fourth, y to the fifth, z to the seventh, minus 10, x to the fifth, y cubed, z to the sixth. Alright, so we can pretty much handle monomial times anything, assuming that we've got enough a piece of paper big enough. Let's go up the ladder and talk about binomial times binomial. Alright, here I've got a binomial of degree 1 times another binomial of degree 1, and of course we'll recognize this as a FOIL situation. First, outers, inners last, and add those four terms together. The first product will give me a 12x squared. The outer product gives me a 27x. The inner product gives me plus 8x, and the last product is plus 18. Now, of course, we can simplify this. There are like terms often, but not always, but often, when you're multiplying binomials in the FOIL process, the inner and outer products end up being like terms which can be combined. So 27x plus 8x is 35x. And of course, you're not correct until you're completely simplified. Alright, so binomial times binomial, think FOIL. Firsts, outers, inners, last. Let's try another binomial times binomial. I get 7y squared minus 4 times 2y squared minus 1. Alright, first product. 14y to the fourth power, applying my rules for exponents, multiplying the first products of these two binomials. Outer product, I'll get a minus 1 times 7y squared, that's negative 7y squared. Inner product, minus 4 times 2y squared, gives me a minus 8y squared, of course. And the last product, be careful of the signs, negative 4 times negative 1 is positive 4. And again, sometimes, but not always, the inner and outer product end up being like terms in binomial products, which can be, of course, combined. So I'll get minus 14y to the fourth minus 15y squared plus 4. And that would be my final return for that problem. Alright, binomials times binomials, we work it out FOIL style. How about binomials times trinomials? I'll give you a simple example thing here. Well, things get a little complicated here, and you start going up the ladder here. I've got a binomial, x plus 4, times a trinomial, x squared plus 2x plus 1. Alright, what I'm going to do is indicate we're going to multiply the trinomial through by the first term in that binomial, then multiply the trinomial through by the second term in that binomial, and combine like terms as needed. I'm going to use what we call the column method. Basically, I arrange like terms in like term columns. For example, x times x squared, that's x cubed. I'll make an x cubed column. And similarly, x times 2x is x times 2x is 2x squared. Positive. And then x times 1 is 1x, or just x. Alright, so I'll make an x cubed column, an x squared column, and an x column, and then I'll arrange my terms in like columns as needed. 4 times x squared is 4x squared, positive, and I'll put that in the x squared column. 4 times 2x is going to be 8x, put that in the x column. And the constant 4 times positive 1 is going to be plus 4, so I'll make a constant column. Alright, arranging all these products in like term columns makes it light work. I'll get x cubed plus 6x squared plus 9x plus 4, because I can combine or add like terms, and there is my final product, x cubed plus 6x squared plus 9x plus 4. Let's try another one, and these can get a little nasty. Let me get a new layer here. Again, another example of binomial times trinomial, and I'm going to do it again using the column method. 2a plus b, a binomial, times 3a squared minus 4ab minus b squared. Alright, notice no constants in either of these polynomials. I'm going to first multiply this trinomial through by positive 2a, and I'm going to arrange my terms in like term columns. 2a times 3a squared is 6a cubed, so I'll have an a cubed column. 2a times negative 4ab gives me a minus 8a squared b. 2a times negative b squared gives me a minus 2ab squared. Alright, and don't forget you've got to multiply everything through by b now. And then again, I'll arrange things in like term columns. b times 3a squared is plus 3a squared b. Alright, so I'll have an a squared b column where I can combine like terms. Similarly, b times negative 4ab is going to be negative 4ab squared. So I will have an ab squared column. And then b times negative b squared is negative b to the third power, has its own column. Alright, some of these are like terms, again, can be combined, some of them are not. 6a cubed doesn't combine with anything. How about this column? Minus 8a squared b plus 3a squared b is going to be a negative 5a squared b. Adding this column, I'll get a negative 6ab squared, and minus b cubed carries down to your final answer. There's my final answer. There's 6a cubed minus 5a squared b minus 6ab squared minus b cubed. Alright, so let's work on some homework problems here. Let's see. Here I've got a binomial, and I'm asking you to square it. 5c plus 3d squared. Alright, let me warn you, this is not equal to 25c squared plus 9d squared. Alright, you might get that erroneous answer by erroneously distributing the exponent 2 over terms of a sum. You cannot distribute an exponent over a sum. Alright, so I'm going to cross this answer out because it's no good. Alright, well, what can we do then if we've got 5c plus 3d squared? Well, when you're squaring a binomial, that really means you're multiplying a binomial essentially times itself. So I can write this as a product of two binomials. Alright, and when I multiply binomials, I work out my FOIL method. I'll get 25c squared as the first product. 15cd is your last product. Notice, plus 15, well, 5 times 3 is 15, and d times c is the same as c times d. So I'll have 15cd as my inner product, and I ran out of room here. Let me add my last product. 3d times 3d is 9d squared. And again, notice these are like terms. The outer and inner product are like terms here and can be combined. Final answer is going to be 25c squared plus 30c times d plus 9 times d squared. There's my final answer. Squaring a binomial, essentially multiplying it by itself. Alright, here's another homework type exercise. Here you are given a monomial times a binomial times another binomial. Alright, well, again, multiplication is commutative, so you can multiply any of these factors first, any two first, and then multiply the result by the third. In this situation, I think I'm going to multiply the binomials together first. That way I only have to multiply through by the monomial once. So my outer product here, my first product here is going to be 6a squared. My outer product is minus 4a. My inner product is plus 9a. And my last product is minus 6. Alright, let me combine like terms before I go on. The trinomial reduces to 6a squared plus 5a minus 6. And now because I've multiplied the binomials together first, I only have to distribute this 4a once. I'll get 24a to the third power plus 4a times 5a is 20a. 20a squared. And finally 4a times negative 6 is minus 24a. Alright, so there's my final return. 24a cubed plus 20a squared minus 24a. Alright, two more I want to talk about today before we call it a day. Again, this is from the homework list. Here we've got a binomial product. And then I'm going to subtract the square of a binomial. Well, clearly the multiplication happens before the subtraction here. So I'm going to multiply this first. And I'll get 10b squared minus 2b plus 15b is going to be a plus 13b, adding the outer and inner products. And then minus 3 will be my last product. Alright, minus b plus 2 times b plus 2. And again, I've got to multiply first before I start subtracting things. So let me just carry this through. Minus, Don't forget to wrap this intermediate result in parentheses. B squared plus 2b plus 2b is plus 4b, the inner and outer products, and then plus the last product is 4. Now remember, to subtract a polynomial, basically you've got to take the opposite, carry that negative sign through. That's second trinomial. Alright, once I've dropped the parentheses, I can combine the b squared terms, gives me a 9b squared. 13b minus 4b is plus 9b. Let me say that again. Plus 13b minus 14b is plus 9b, and then minus 3 minus 4 is minus 7. So there's my final result for that somewhat complicated problem. Last one. Example. X minus y times x plus 2y times x minus 2y. Alright, here I've got a product of 3 binomials. Well, I suppose I can multiply any 2 together first. Multiplication is commutative and associative. What I'm going to do is I'm going to multiply these 2. I think I see something happening in that second product. So let me go ahead and carry down x minus y to the next step, and I'll multiply this binomial next. The last two binomials first. I'll get x squared minus 2xy is my outer product, plus 2xy. Hang on, I made a copy error here. Let me start again. And I'm looking to multiply those second 2 binomials first. Give me a second here. Alright. First product, x squared. Outer product, minus 2xy. Inner product is plus 2yx. Well, that's equivalent to 2xy, is it not? And then the last product, minus 4y squared. Now, hopefully, the observant can realize the outer and inner products here are opposite, so they cancel each other out. So I end up with x squared minus 4y squared as the product of those last 2 binomials. And now I've got another binomial times a binomial. I'll grind this out FOIL style as well. X cubed, the first product, minus 4xy squared, the outer product, minus x squared y is going to be the inner product, plus, be careful of the sign, plus 4y cubed is going to be the last product. And notice, none of these are like terms. This cannot be simplified any further. So my final answer is a 4-term polynomial of degree 3. Alright, that's the last example for today. We'll call it a day. This concludes section 5.4, Multiplying Polynomials.